Hi, in this video, I'm going to show you how to set up custom face recognition service using Amazon Rekognition AI service at AWS. As you see in this picture, or as you see in this screen, this is a pictorial overview of my demo, which depicts how does this face recognition service works at AWS. Yeah. So as normal, in my videos, I'm going to explain you the demo into the two parts. In the first part, I'm going to explain you how does we set up these components so that we experience this service, and in the second part I will show you from scratch to end how you can configure these components together, and finally I will show you a real-time demo that how does this service actually works. Yeah. All right, so before I start with my first phase of my demo, a kind request, please do subscribe my channel. That would really encourage me a lot. Yeah. So with that note, let's directly jump to the first part of my demo where I'm going to explain you this pictorial overview of the flow. Yeah. So as you see in this screen, okay, so when I say face recognition service, this is a custom face recognition service. Okay, it's not it's not using the default library of the Amazon recognition service, but you're gonna create your own containers, and also you're gonna use that container for doing a face recognition service. Yeah. All right, so here we are using four types of major services. Majorly, we are using Amazon Rekognition AI service for face recognition purpose. But along with that, we are also taking help from the other services like S3 bucket, Lambda, and DynamoDB. Yeah. So with using these four services, I have made a custom face recognition service. Okay. So let me tell you how does this workflow works. Yeah. So basically, here you see, right? So this is the desktop. What you see, this is the laptop, right? So laptop hold a professional holding the laptop, yeah. So the person who wants to consume this face recognition service, what he will do is he will upload an image. It can be a JPG, JPEG, PNG, yeah. So he gonna upload an image to Amazon S3 bucket, which is created in this service. Yeah. So once the image is uploaded into this S3 bucket, so this S3 bucket gets makes the AWS Lambda. We call it as a face recognition processor Lambda. You can call it as, yeah. And this Lambda gets automatically triggered, and when it triggers, it does certain tasks. All right. Upload triggers. That is what we call it as a whenever there is a file upload into the S3 bucket, that triggers a AWS Lambda instance, and the Lambda has a logic to process the image. Okay, what does it process? It will give this image as an input to the Amazon Rekognition service and request for a index faces. In the sense, it will ask for the what is the index of this face. In the sense, it will ask for the image thumbprint from the Amazon Rekognition service. Okay. So once it queries the index face index or thumbprint from the Amazon Rekognition service, Amazon recognizes responses with that thumbprint, and with using that data, it also the Lambda also does the second step that it going to it also uses that thumbprint and the metadata of the image file and puts under the DynamoDB in a particular table. We're gonna create that. I will show you how we can do that. Right. So it populates the index and the respective metadata into the DynamoDB table. Okay. So basically, this is how this is how actually it works. Yeah. So this is like a kind of you are creating the dictionary of your faces, and then you're gonna use the then you're gonna use that dictionary to identify your faces whenever there is a need, whenever there is a business need. Okay. All right. So that is the first phase of the demo, first phase of the flow. Then now let me go to the next phase. Okay. The next phase is let's say that you are ready with your face recognition dictionary. Yeah. Maybe you want to check what is this image is belongs to my dictionary. You want to identify, yes, is this image belongs to any of the faces I have recorded in the Amazon recognition collector. Yeah. So in that case, what he does is this from here this professional will going to invoke the image. He will take the image as an input and try to identify whose face is. Okay. That is where this arrow tells about. Okay. Search face by image request. The request will be directly put across to the Amazon recognition service, right? And when the request is put across, right, then Amazon recognition service, what it does is it actually returns a face matches. Yeah. And when the face matches is get returned, right, then again we have the logic within the script. Okay, I'm going to use this. I'm going to show you how did I achieve this in the later phases. But yes, when it returns a matches, it actually goes and checks the DynamoDB, right? So in the DynamoDB we have kept like key and value pairs. Okay, and that's nothing but this thumbprint of the image belongs to this face name. Yeah, so that data will be kept in the DynamoDB, and finally you're gonna get whose face is that. Yeah, so yeah, so that's all. So basically this is how all these four components work together, and finally we realize this is a custom face recognition service with using Amazon Rekognition AI service. Yeah. All right, so this is all about the pictorial overview. Maybe this is a bit complex. Yeah, I will also explain you from the scratch to end how we set up this component first, and then I will show you the real-time demo, like whenever we are querying a particular image to identify whose face is this, then we're gonna get a required proper response from the Amazon Rekognition. Okay. All right, so with that note, let's directly jump to the second phase of the demo, where I'm going to show you everything from the scratch in regards to this this face recognition service. So I have articulated certain steps that you need to follow to set up this infrastructure, or to set up this face recognition service at your AWS account. Yeah, and those steps are being articulated here. Anyways, I'm going to share you all the scripts, example faces, example PNG files, everything at my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find the file from there. Yeah, okay. All right. The first step is we need to create a bucket. Yeah. Then we need to create a recognition collections, that which is I have explained, right? So let's go one by one. So first of all, I will tell you in this video, I'm using Visual Studio Code to run AGCLI and also to run the Python Boto 3 module from this one. Okay, maybe you can use any other services, but I choose to use the Visual Studio Code. Maybe you can use the any other, maybe PyCharm as well. Yeah. All right. So before we start with the first step called, create a bucket called face collection bucket. Okay. So for that case, what I need to do is I need to set up the context of my AWS account. Okay, so if I can go back, so this is my AWS account right now. I'm in the Mumbai region. Okay, so let me switch back to the Mumbai region. So this is also my AWS account. Okay, for your information, all the four tabs are belongs to my AWS account, but I have opened the respective services in a different tabs. Okay, don't get confused. So first, what I'm doing is I'm setting Amazon S3 bucket with using AGCLI, and that too from Visual Studio Code. All right. Now, to run that command, I need to set the AGCLI context. Okay. For that case, I need to run the command called AWS configure. All right. AWS configure. So I'm going to run this command called AWS config. Yeah. And what it actually going to do is, basically AWS configure. So what is actually does this? What does this command does actually? Okay. As you might be knowing, AWS CLI is like a command line interaction tool that you can interact with the AWS account. And here, when you run the command AWS configure, you are setting the context, in the sense you are authenticating, you are authenticating the account, and you will be authorized to work with that account. Okay. So here I am providing my AWS access key. This is my AWS access key, which is already provided. I'm okay with it, and this is the secret key it is showing. And then I'm setting the default region to AP South 1. Then the default output format is JSON. All right. And then that's all. So you need to provide these inputs so that the AWS CLI sets the context for you. All right. So the next step is to verify if you have set the context clearly or not. For that case, you need to check AWS STS, secure token service, get caller identity. Yeah. So why do we run this command is because we want to validate if we have already set the context properly or not. Yeah. So get caller identity. Let me run this command. It should return something. Okay. So if it runs something, then which means that it has set the context clearly. Here you go. I'm using the AWS user access. Okay. So this is my AWS user, and let me tell you, it has a admin permissions. Maybe in your real-time project or even your real-time production, maybe you need to minimize the required permissions. Okay. So to help you that, again, the required permissions for this demo is something like this. Okay. You need to have the full access on the Amazon Rekognition service, DynamoDB, S3 full access, and Amazon, maybe IAM full access, and AWS Lambda full access. Okay. Give full access only on the services where your workflow is working. Okay. That's a initial basic recommendation for least privileges. Okay. Again, that's again bottom line. Again, within the services which you are consuming, you may again limit the permissions as well based on your business functionalities. All right. Right now we have set the context. Let's go and run the command. Let's create a First we need to create a S3 bucket. Okay, I will not create S3 bucket with using CLI, but I will just use the GUI. Okay, I use the portal. So here I'm going to give my bucket name something like this, and rest all I will keep it default. Okay, I'm not going to do anything. I just click on the bucket create. Now here you go, right? Our bucket is ready. So let me go back to the picture. So this bucket is ready. Okay, for your information, now I'm setting custom face recognition service. Okay, well, I'm currently setting the infrastructure required for custom face recognition services. Yeah. All right. So the bucket is ready. Now let's go and set the next component. Let's say Lambda. So for that case, again, let's go to the function. I'm in AP South region. Okay, so if I can show you the region. So this is AP South 1. So in this region, I'm going to create a Lambda. Yeah. And let's call this Lambda as, face recognition service. Okay, so face recognition Lambda. All right. So let me call this my Lambda name as face recognition Lambda, and I'm choosing the template equal to author from the scratch. I'm not using the other templates. Okay. Face recognition also, this is the function name, and the runtime I'm going to choose the Python 3.8. Okay, because I always love to have n-1 versions. Okay. All right. And after that, you need to change the role. Okay. So role, as I said, I'm using some very highly privileged role for this demo. Maybe you need to refine these roles when you are deploying this service at the production level. All right. Then we're going to create a very blank, AWS Lambda. The Lambda is ready now. Okay. All right. So our second component is also ready. Yeah. All right. Yeah. Now let's go to the next command. Okay. So next command is, next thing is, we are done with the IAM role. Next one is we need to set up the third component. If I can go to the diagram, I was following the diagram, right? So we created a S3 bucket. We created AWS Lambda. Now let's create this, Amazon recognition service. Okay, Amazon recognition service is something like this. Okay, you don't need to create any instance of Amazon, recognition service. It is like a very wide container. You can call it as, let me call it as it's a Amazon recognition service is a wide container. In that one, you need to create a small collections. Okay, where you can play your, where you can host your custom AI services, or where you can play with your custom AI services. All right. So for that case, what we need to do is we have to create a collection container, right? So for that case, I need to run this. Okay. So I'm gonna leverage AWS CLI command to create the collections. Right. For that case, let me run this command. So the command is AWS recognition. Okay. So let me select this. Maybe I need to make the screen very big so that you can see the commands very easily and clearly. All right. So this is the command I'm executing now. AWS recognition, create collection ID. I'm giving the collection ID equal to family collections, for example. Yeah. And the reason I'm choosing is AP South 1. Okay. This is very important. Make sure that your reason is same across the services. You can ignore the S3 bucket because S3 bucket is, global service. All right. Now let me hit the enter. Basically what we are doing here is, we are creating a collection. What is that collection? That is a, kind of a container within our Amazon recognition service hosted in the AP Southeast region, AP South 1 region of AWS account. Yeah. All right. Now we are done with the, our services. That's the third service, that is Amazon recognition service. And we have one more service which plays a role in this face recognition service, right? What is that? That is DynamoDB. So I'm going to again use, DynamoDB. I'm going to use the AWS CLI command to create the DynamoDB and the respective, partitions within that table as well. Okay. So this is the big command. I will share this script anyways. You can try it from your side as well. But for now, I'm going to run this command directly from this console itself. The command is very big. Let me walk you through this one. AWS DynamoDB create table. This is the table name. Again, I'm giving the table name as same as the container ID. And the attribute definition equal to, the attribute name equal to, I'm using, recognition ID. Yeah. And the attribute type equal to S. Schema is equal to, again, recognition ID. Yeah. And that's also basically, I'm using the read capacity unit equal to 1, write capacity equal to 1, and reason equal to AP Southeast 1, AP South 1. Yeah. All right. Now, if I run this command, basically what it does is it's gonna create a table for you in the DynamoDB, and also it's gonna create a partition required, required column structure or schema definitions within your AWS Lambda as well. Sorry, AWS DynamoDB as well. Let's go to this one. So this is it's again my same AWS account, yeah, and I'm in the Mumbai region. Earlier there were no DB. Let me refresh because just now I have ran it, and here you go, right? So the partition key here we have identified is Rekognition key. So if I go to this DynamoDB table and click on the explore table item, right? And right now there is no, so okay, the returned item is equal to 0, right? This is kind of a database. This DynamoDB table is going to act as a database for your face recognition application. Okay, so here we are not building, or we are not writing very deep hard codes, or deep high level code. We are not writing it here, okay, because we are reusing the AI services provided by the AWS and creating our own custom face recognition services, which is required for your business or for your need or whatever you want to do. Let's say this is here is the use case is just to recognize the faces. All right. Okay, so that is the reason these are the 4 services of AWS coming together and helping you and providing you a service called face recognition service. Okay, now we are almost done with the required component setup. If I can reiterate, we created S3 bucket, we created AWS Lambda, we also created a recognition service. In that one, we created a collection. Yeah, we created a collection container within the recognition service, which we can use in this demo. And we also created a DynamoDB and also created a partition key within it. All right. So now let's go to the next command. So what is the next command is, we need to set up this, we need to set up, we need to make the connection now. Okay. So now all the 4 components are independent components. This does not mean that, you have you have set the face recognition service, right? So for that case, let's come from the S3 bucket. In the S3 bucket, let's create a container called, a small container or folder called index. I'm going to use this index folder to store all the faces that I need for my application. All right. So let me call it as an index. So if I go to this one, and yeah, so I have given I will explain this file anyway. So I will go to the index, and index is the folder number. Yeah. And that's all. I'm going to create a folder number called index. And under this index, we are going to keep all our faces dictionary. You're going to dump all your face PNG files or passport size, photos. You can put it in this, subfolder. All right. So this is the first thing that you need to do on the your S3 bucket. Now let's go to the function. So here we need to do multiple things. So before that, I will explain you the configuration that you need to maintain at this AWS Lambda one after the other. The first one, go to the configurations. Let's fine tune the configuration. Okay, so in the general configurations, if you see, right now it has very limited memory and the very limited ephemeral storage. We need to increase those because we are performing bit very lengthy processing. That's the reason I would recommend to increase the memory and the ephemeral storage of your Lambda to this 1 GB. Yeah? And also make the timeout equal to 15 minutes because Lambda also can run up to 15 minutes. So let's consume all the, okay, let's set the threshold equal to 15, which is complete threshold. Yeah. All right, that's the general configuration we have updated. Now let's go to the second trigger. Okay, that is a trigger. So as I explained here, whenever you are uploading a JPG file or image file in this bucket, it should trigger the Lambda. So for that case, what I have to do is I have to configure the trigger on this Lambda. So click on the triggers, add triggers. In this one, choose the service called S3 bucket, S3. All right, in this one, now we're gonna choose the same bucket. Okay, so if you see the face collection bucket is my bucket. And in this one, you have to choose, the all object create event. What does this mean? In the sense, whenever you are uploading something into that S3 bucket, this Lambda gets invoked. Yeah. And also prefix. Prefix is nothing but subfolder that you would like to have underneath one. Okay. So nothing but whenever somebody is uploading a file, okay, whenever somebody is uploading a file under this folder, under this subfolder of the bucket, then this Lambda gets invoked. That's what it means. Okay. So you need to put the syntax something like this. Okay. This is your subfolder within the bucket and /. All right. and that's all. So you just need to acknowledge it and add it. Okay, that is all. Okay, so that's all that you need to do the configuration level changes in this Lambda. And there is a one more step left over, which is very important step, that is refining the code. Okay, for now it's very basic code. Okay, it has nothing, but it returns only status HTTP status equal to 200. Yeah, that's all. So now what I do is I'm going to show you like what is the Lambda that you need to know, what is the logic that we need to write in there in that Lambda, so that it actually does the required things. Okay, what is the job of the Lambda here? Okay, whenever there is a invocation from the S3 bucket, that event will have bucket name and the key name, in nothing but which file is uploaded, what is the file name, and what is the bucket name. Yeah, and also the metadata related to that, the key. Okay, that is a S3 bucket key or S3 bucket file will be there. So basically what it does is, whenever there is a file upload, it will read, it will see what kind of image, okay, which image it has uploaded. It will retrieve the metadata related to that. Yeah, it will retrieve the metadata related to that image file, and it will use that image file and queries with the Amazon Rekognition service to identify the index, nothing but to identify the thumbprint of the image. Once the thumbprint is retrieved by the Rekognition service, it will store that data into the DynamoDB. There are the three tasks here. Okay, one is read the S3 bucket, read the S3 event, query the Amazon Rekognition service, and finally put the data into the DynamoDB. So these are the three tasks it's going to do, right? So that's the reason. Let's see the logic. Okay, so I have already written the logic. Let me walk you through the logic, and I will upload the data. I will upload this code into the Lambda. Okay, all right. So this is a very simple Lambda. So here what we are doing is we are using we are basically using multiple things here. Let me delete this because we don't need that. Okay, so okay, let me do Control Z. That's right. That it's okay to keep this. Okay, all right. So here I am importing. So this is nothing but this is the AWS Lambda Python file. I have only Python file, and I'm going to walk you through this code and what is the logic I'm writing. Okay. So first of all, let me tell you what is the thing that I'm importing. So that is from this print underscore function collection, import the future function. Okay. And we are importing the Boto3 module, we are importing the decimal, JSON, URL lib as well. And finally, we are printing at the first line of the code, we are printing the loading the function. And finally, we are setting the client of the AWS DynamoDB service, right? With using Boto3.client module, and this here is the client, yeah. And also we are loading the client for S3 bucket as well. And finally, we are also loading the client for Rekognition service. Okay, that is where. So if I can go back to the picture again, this Lambda is interacting with the S3 bucket, Amazon Rekognition service, and DynamoDB, and that is where all the clients are getting loaded here. Okay, so DynamoDB, we are creating a client for DynamoDB, S3 bucket, and Rekognition service. Okay, so let's keep this in mind and let's go down. Okay, and for this case, we have written helper functions, and these are the helper functions. One is index the faces. What does this index faces function does? So basically, it uses two parameters, a bucket and the bucket key name, yeah, and it invokes Rekognition's service API called index underscore faces, and in that one it provides a parameter called the S3 object, and in that one bucket name and key name is been provided, and we are pointing to the collection which we have created just a while ago, if you remember. Okay, so this is the collection we are pointing. Okay, and what we are doing is what is this basically? This this API does is it's going to create an index. It's going to create a thumbprint. Okay, it's going to store a thumbprint in the Amazon Rekognition service in a collection called family collection. Okay, that is what it generally does. Okay, that's the reason index underscore faces API is used, and in the response we are returning the response. Yeah, and let me go to the next functions. In the next function, update the index. Okay, as the name says, we are storing some data into the DynamoDB. So here the parameters are table name, face ID, which is nothing but thumbprint of the image from the Amazon Rekognition service, full name, yeah, nothing but this is a metadata that we are storing on the face file, face image file which we are storing in a S3 bucket. And we are invoking a DynamoDB API called put item, and these are the parameters. Okay, this is a table name, and the item. Okay, in this item, it has a recognition ID, which is nothing but thumbprint ID, and this is the full name. Full name is nothing but it will be retrieved from the metadata of the file which is stored in the DynamoDB. Right, these are the helper files. Now let me go to the handler files of the handler code of the Lambda. So in the handler, if I can scroll a bit, maybe you can view it very clearly. So in this one, we are printing the event, so nothing but the event which triggers this Lambda, getting the bucket name from the event. This is the bucket name and key, and this is the format that you can follow. Okay, under the try and catch block, basically what we are doing is we are invoking. So here is the place where we are consuming the helper function. One is we are calling the index faces function and getting the response. Okay, this is the function we are calling and getting the index of the the image file. Okay, and if there is a index ID present, then only we are going within this if block. Okay, yeah, and also when there is a index, when there is an index is present for that image in the recognition service, or let's say index is created in the recognition service, then we are retrieving the the head object, nothing but we are retrieving the metadata of the key, metadata of the a key within the S3 bucket or a file within the S3 bucket. Again, it's again image only, yeah, and we are getting the full name, nothing but we are retrieving the full metadata of the image file, yeah. And finally, we are invoking the DynamoDB function called update index, nothing but we are creating a item, nothing but we are inserting certain data within the within the DynamoDB which we created, right? And this is the DynamoDB, and this is the the row. This is the nothing but one record, that is a face ID and the personal name, full personal name. Okay, that is the one record within the DynamoDB table. And finally, we are printing the response. Okay, nothing but the response from what we got from the indexes. And they, we are also catching the exceptions. All right. Now let me copy this code quickly, and what I'm going to do is I'm going to update this code into this file. Okay. All right. So let me store this file. Okay. This is how basically in my general videos I will show you the configuration with using manual. Okay. So I believe that first you try to understand how does it works with using the manual operations, or understand the the functionalities, tricks and tips of the services. Then you can do it with using the any code, any infrastructure as a code, everything, blah, blah, okay, which is actually booming. Without having the knowledge of the service, if you go and do the infrastructure as a code with using Python, Terraform, CloudFormation, blah, blah, right? It does not make sense, okay? Basically, you need to understand the service, okay? That is what I can understand. That's what I understand, I recommend for you, yeah? All right, so right now we have updated the S3, we have updated the AWS Lambda now. Now let's go to the next step. What is the next step actually? Okay, so the next step is let's upload some let's upload our dictionary. Nothing but you have one like 10,000 face images, right? Or let's say you have million face images. You can upload those face images in this S3 bucket, and you create a records of those faces in the DynamoDB with using this Lambda. Okay, for that case also I'm not going to do this manually. I have written the script. I will explain that script, and we will run that script from here only. All right, so the script which I have used for that one is, so bulk face picture upload to S3 bucket with metadata, all right? So for that case, what we have done is I have written this very simple script which is uses the S3 bucket Boto3 module, which uses the Boto3 Boto3 SDK for S3 service, and we run the certain APIs on the S3 bucket to upload the file and configure the metadata of the files. Okay. All right, so again, we are importing so let me walk you through this code, and I will explain this, I will run this code, okay? So here we are importing the Boto3 module, and we are importing the resource, S3 resource, and here is the some logic, okay? Here, get the list of object from the index, okay? What does this means? So basically, I'm not doing here anything, nothing but, what we are actually here doing is, you can ignore this one. What I'm doing is I'm creating a list, right? I'm creating a list of tuples here. I can call it as a list of tuple here, and we are using this list of tuples, and we are using this list to iterate and upload the files into the S3 bucket. Okay, so for that case, I will just walk you through this one. So here, as I said, we are creating a storage of our faces, right? So here I have used some iconic personalities. Some of the scientists, some are sport personalities. Okay, renowned sport personalities and renowned scientists are there. So I will show you what are those faces, and I have created this list of tuples. Okay, if I go back to my my page, okay, my file where I have kept those image files. So let me go to the image files, and where is the image file? So this is, let's go to this one, and Python hacks, and here is the face. Okay, so this is where I have kept the file. So Facebook, I have given the name equal to Facebook. What is this Facebook? This is not as Mark Zuckerberg's Facebook, but this is my Facebook. Okay, all right. So I have kept the collection of the faces. That's the reason I called this as a Facebook. All right. So it contains these renowned personalities photos. Okay, especially face photos. Right. One is the you see this Indian our national scientist APJ Abdul Kalam. Then we have a CV Raman. Then we have a David Beckham. Okay, who is a footballer. Then we have the scientist. It's Albert Einstein. Then this is Isaac Newton, Sir Isaac Newton. Then we have Lionel Messi, Tesla, Ronaldo, and finally Sunil Chetri, again a footballer from India. All right. So what I'm going to do is from this file, I'm going to upload all the file in one shot into the S3 bucket with using this code. Okay, that is where the code is, and that's where I have created this dictionary of the tuple. Now I'm going to use this. I'm sorry. This is the list of tuples. With using this list, I'm going to iterate and upload into the S3 bucket. If you see, all right, we are using put operation and uploading into there. All right. So before you run this script, I will recommend it to CD to this path. Yeah. So go to this one and do the CD. Right. So I'm going to do the CD here. Right. And I'm going to run this command because I have already set the context. Okay. How does this file running from this, running from this Visual Studio Code is because, by virtue of the AWS CLI context. Okay. Boto 3 again consumes from the backend, it consumes the context of the AWS CLI. That's the reason Boto 3 will work, even though I'm not setting any, hard-coded credential configurations from in this file. Okay, it will leverage the underhood profile. Okay, all right. So what we are going to do now, we are uploading all these image files into this S3 bucket. Right now there are 0 objects. Let me run the script. Yeah. Anyways, this file will be shared in the GitHub repo, and the GitHub repo link will be shared in my video's description. Maybe you can use this file from there when you are trying to do it from your side. Okay. All right. It will take some time because right now we are uploading 9 files. All right. So it has ran successfully, and the 9 files got uploaded with the required metadata. Here you go. Right. All the 9 files are being uploaded here. If I open one example JPG file, and if I go to the metadata, all right, it contains a metadata. This is where it plays a vital role. Okay, so remember, we are adding some user-defined metadata for this one called full name, right? xamz-meta-full name. Okay, this is the full name is the metadata we are keeping, and the value name is the image name. Okay, that is APJ Abdul Kalam. Okay, this becomes a standard reference dictionary for your application. Okay, now once we upload this file, automatically this AWS Lambda gets triggered. And I'm going to show you in the, whether this Lambda got triggered or not. Okay. So if I go to the view CloudWatch logs, and I'm going to show you the logs. Okay. And finally, we will also see, if the records are being inserted into the DynamoDB or not. Okay. All right. While that opens, I'm going to go back to this table because the opening the CloudWatch logs takes some time. And we're going to go this one, and we're going to create, we're going to say, view items, right? So, and let's run this one. Okay, here you go. Right, it has actually created the required records. In the sense, this Lambda, this face recognition Lambda has already done its job. Okay, so if I can go back, whenever somebody is uploading the file, it iterates through each file, gets the face index from the recognition service, right, get the metadata from the S3 bucket, and stores into the DynamoDB, populate index into the DynamoDB. Yeah. All right, and that is where it happened. Okay, if I show you the recognition IDs these are recognition ID, which you can generally think it as a picture thumbprint. Okay, and this is nothing but what is this Amazon recognition service doing in the backend? In the backend, it is analyzing the picture. It is it is summarizing the picture in the picture terminology. Okay, so if there are some picture expert, maybe it will store the thumbprint. In the sense, the thumbprint will contain how much pixel, where is the, where are this color is there, what is the color. Okay, that is a very, picture science. Okay, you can call it as a picture science. Okay, so based on the picture science, okay, each image will have its own equation. Okay, and that equation data will be stored in the Amazon recognition service, and that data will be used to recognize the image uniquely. And And after that, we will get a one single reference called, thumbprint, and that thumbprint has been uploaded here. Recognition ID and full name, okay? Here you go, right? You see the Sunil Chetri, C.V. Raman, Nikola Tesla, right? Albert Einstein, David Beckham, Lionel Messi, APJ Abdul Kalam, Isaac Newton, right? Then Cristiano Ronaldo. Already, so all those images are been uploaded, and Lambda has already done its job, okay? And finally, I will show you, the log has run, okay, successfully. If I can open this log, and here you go, right? So basically what it actually doing is, it is using the ninth, it's actually nothing but, it's getting the bucket name, it's getting the file name, and it is uploading that file into the, it actually retrieving the data, and it's actually, uploading the data into the DynamoDB. All right, so now what we are done, okay, so we have successfully, established, we have successfully set up this thing, okay? Nothing but we have successfully created our custom face recognition service with using Amazon Rekognition service. Now the time, okay, now the time to use this service or consume the service. Before you consume, what do? We do the testing, right? So this is the time where we are actually testing. To test also, I have already pre-created one Lambda file. I will just, no, I have created run test, okay? I have created a run test underscore detect face, right? This is a script, again, Python script, which will, which will invoke the, command against the Amazon Rekognition service and try to get the result, okay? So let me walk you through the script, and this is the time to test our, face recognition service which we built, yeah? Basically, it's a very simple script, okay? I will just walk you through this one. Here again, we are using the Python Boto3 model, Boto3, IO, and images, right? And here we are creating some clients belongs to the recognition service and DynamoDB. Why we are doing this? Because we need to query the DynamoDB, and also we need to query the recognition service, okay? Then only we can identify which face is it, okay? Basically, let me tell you again, Amazon Rekognition service does not has that, it's an artificial intelligence service, but it does not, it is not that much artificial intelligence that, it can tell you at once, okay? You need to, the service has been constructed to consume it, okay? You need to consume it, you need to articulate it, and then you need to consume it, okay? That's what I can recommend, okay? So basically, it is helping you to build your own artificial intelligence service, okay? That is the summary of the Amazon Rekognition service. So we are loading the client, DynamoDB, and we are opening one page, okay? So we are opening, here, I'm feeding some input in the sense, let's say, let me go back to my picture collections, okay? This is the Facebook. Now let me go to the detect book. So detect book again, if I can explain you, so these are nothing but again, these are the images belongs to those same personalities which we have uploaded through the Facebook, through the another folder. But these images are not exactly like those images which I have uploaded, okay? These images are something different. If I can show you again, let me go back. So here, the Sir APJ Abdul Kalam's photo is something like this, okay? But if I can go to the another folder, that is a detect folder, but this is the picture I'm going to use to identify who's he, right? Here is so the pictures are different. So this is the Einstein, this is Cristiano Ronaldo, this is Beckham, right? I know it, but I want application to tell this. That is what face face recognition application has to do it, right? So these are the different pictures of the same personalities which we have, added as a dictionaries, all right? So now the time is to test it, okay? So here again, we need to change that, okay? You need to switch the directory to the directory where you have kept the file and you want to identify those faces. For that case, I am switching back to the CD to the detect book path, and from there, we're gonna ask who is this, okay? One after the other. All right, so let me walk you through the code again. Here, we are using the IO byte, bytes IO functions, okay? Here we are using the stream byte IO, and we are using the, we are using the stream, nothing but, here the input is image itself, okay? That image is converted into the, byte IO and fed as an image, okay? Fed as a binary. So what actually we are doing is, you have an image, you are converting that image into the binary data, and you are feeding that binary data to the Amazon Rekognition service, okay, to get the thumbprint of the Amazon Rekognition service, okay. All right. So first one is we are using the function. So we are using the client recognition. We are using, then in that one we are invoking the search underscore faces by image, okay. So in this one we are targeting to the same collection ID which is meant for our application, right? That is family collection, right? And in this one we are giving the image. In the image we are telling that I'm giving you not my image, but the image binary information, okay? Each image can be decoded into binary. And that is where the data is been fed as an input here, right? And you will get a response. What is that response? The response is nothing but that's a thumbprint of your image, right? I'm going to use that response and query to my DynamoDB table, right? That is what we are doing. So for each face matches, print the face match, yeah, and with using that face match data, or with using that face match ID, get the item, okay, get the item from this table called family collection, where the recognition ID is equal to this one, all right? And finally, we retrieve the response. In the response, we are going to get what is the full name of the, that particular face, all right? And that is what this does. All right, so here, for the first one is NT. What is nothing but that is NT is, Nikola Tesla, all right? So under this path, detect path, there is a NT file, right? This is the NT file, right? If I can show you, this is Nikola Tesla's another image. If I run this, it has to tell it is a Nikola Tesla, okay? All right. Now the time to run our script, okay? So for example, let me run this script now. I will run this script. What is actually doing is, it is reading the file and it is invoking the Amazon recognition service, and also it is querying the DynamoDB table, right? Here you go. It has told, okay? So it has telling that this is a Nikola Tesla, and the confidence, if you see, the confidence is equal to 99%, okay, which is very high, right? And it that much accurately it is telling, okay? So that's also, I have successfully shown you the thing to be shown in this video, right? Now let me test another images as well. So let me test the Albert Einstein's one, okay? Why I'm giving this AE JPG? So nothing but the file names, right? I have given some file names, and I'm going to quickly show you, it also identifies that. If I run ae.jpg file, nothing but I'm feeding the Albert Einstein page, and it is telling that it's Albert Einstein exactly 99%, okay? Which is very high confidence. Right, I will go to the next one, that is CR7, that is a Cristiano Ronaldo 7. So let's see if Cristiano Ronaldo getting identified as expected, right? And let me save this and I will upload this. Right, so I think file name is wrong. So let me go to this one. All right, so Cristiano Ronaldo file name is JPEG, okay? That's the reason it is throwing the file. So Cristiano Ronaldo JPEG. And save this one and run this script. All right, he's telling the face identified is Cristiano Ronaldo, and the confidence is very high. Right, let me show you the last face. Let's see our Lionel Messi, okay? So LM Leon Messi, okay, and let's run the script. So yeah, so here you go. It has identified it's a Lionel Messi and the confidence is 99%, okay? All right. I have successfully shown you the things to be shown. Finally, the wrap-up conclusion. So here, we have set up the, complete custom face recognition service with using S3 bucket, Lambda, DynamoDB recognition service. We made a connection between these two services. We fed an example, collection of images into the S3 bucket, and that S3 bucket has been processed, and the required backend table database has been created in the DynamoDB table, where it leveraged Amazon recognition service capabilities to create a face indexes into a custom collection, right? And we created a database, okay, required for our face recognition service, which is called as a custom face recognition service. And finally, when we are feeding the data, we fed the same faces like which is chosen, and we try to query the recognition service. We have got a proper response saying like, these are the respective faces are being identified with a high confidence, okay? Okay, for now, I have successfully shown you the required things to be shown in this video. A kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, thank you. Thanks a lot.